In 2009, Tony Hoare, a renowned computer scientist and mathematician, apologized for inventing the null reference while speaking at a software engineering conference. He expressed his regret for what he described as a billion-dollar mistake and acknowledged that null references could lead to potential software vulnerabilities and unexpected errors. "I call it my billion-dollar mistake. It was the invention of the null reference in 1965. At that time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. That's how Tony Hoare described his mistake. Today, we'll be talking about two of the biggest mistakes in computer science. First of all, let's define what null is. In most programming languages, null is a special value that represents the absence of a value or a null pointer. It's used to indicate that a variable doesn't contain a valid value. In other cases, it indicates that a reference points to no object. While null might seem like a useful tool at first, it can actually cause a lot of problems. One of the main issues with null is that it's often misused and misunderstood. Many programmers treat it as a valid value, rather than as an indicator of an error or an exceptional condition. And this may lead to bugs that are difficult to track down and fix. Another problem is that it can create confusion when it's used as a placeholder for missing or undefined data. Imagine a database table with a column for a person's middle initial. If that person doesn't have a middle initial, the cell in the table might be filled with null. But what does null mean in this context? Is it an empty string, or does it indicate that the person simply doesn't have a middle initial? This ambiguity can lead to errors and inconsistencies in the data. Null can also cause performance issues. In some programming languages, checking for null values can be slow, which can impact the overall performance of an application. And in some cases, null values can even cause a program to crash. Null has caused a lot of problems for programmers over the years. Therefore, it's important to be aware of the issues with null and to use alternative solutions whenever possible. On March 1968, the computer scientist and science essayist Edgar Dijkstra published a paper called "A Case Against the Goto Statement," also known under the name Goto Considered Harmful. In this paper, he argued that Goto statements should be abolished from high-level programming languages. The reason, according to Dijkstra, was that they complicate the task of analyzing and verifying the correctness of programs, particularly those involving loops. The statement, which enables a program to jump to another part of the code, was widely used in early programming languages. Later, it was discovered that unrestricted use of these statements can make code hard to comprehend and maintain. These statements caused several issues, such as spaghetti code, which made debugging and maintenance difficult. To address these issues, structured programming paradigms, exceptions, coroutines, and message passing techniques that don't rely on Goto statements were invented. In this episode, we've seen two common mistakes that were introduced into programming languages. They created a lot of problems and confusion, making programs harder to read, debug, and maintain. That was another episode of 5 Minutes Programming. Don't forget to subscribe to our channel to be notified when we upload new episodes. Check the links in the description for more information. See you tomorrow.